welcome to my fourth video in this series about energy and ecosystems, and today we're going to be looking at biological pest control and integrated pest management. So biological controls, so you can control pests by using chemicals. Another way to do this is to use living organisms to control pests, and so it can rely on things like predation, so feeding, parasitism, herbivory and other natural mechanisms. But essentially it involves releasing a living organism to control the numbers or the population of a different species that you're trying to limit. And so some of the advantages of this, you obviously don't need to introduce chemicals to an area. Obviously you don't build up a resistance, so the pests don't become resistant by using biological controls. Control organisms will increase in number and spread, and so you can start with a small sample, a small start point, and according to the number of things that they're trying to predate, then their numbers will increase. And selective, it doesn't intensify or create new pest problems, or it shouldn't. The disadvantages, sometimes the control is slow, it doesn't fully exterminate the pest, it's often unpredictable, so that means that it could lead to that organism then becoming a pest, and we'll look at a couple of examples of that. It's usually difficult and expensive to develop and supply, and obviously you need to monitor it constantly. It's not a simple thing to carry out, so it requires a lot of in-depth knowledge, and therefore it needs close monitoring. And a couple of examples: the use of grass carp to control weed growth in ponds and waterways, and the control of a waterway hyacinth with weevils. And so there are numerous different examples, like some of these here. You have, for this instance, you have controlling the numbers of specific caterpillars you could use, certain flies or wasps in some instances. Obviously the well-known example is using to kill aphids is with ladybirds. You can use some forms of mites, and these can control feeding upon other mites, and so therefore they can, these other mites will feed upon your crop and then reduce the yield. Some things that are used on slugs, and some things which are widely available which kill weevils and in some cases kill slugs. So a common example of a biological pest that has then become a pest itself is cane toads. Cane toads were introduced to Australia to control a number of these greyback beetles. The problem that they had was they didn't fully take into account the effect that the cane toad would then have upon the ecosystem, and so parts of the problems that they had were the beetles weren't out at the same time as the cane toads, and the cane toads were much better adapted to wetter conditions, and so they migrated from the sugar fields into other areas, and because the cane toads had a venom and a poison, they then became much better suited to the area than a lot of other things that were there, and so they weren't really predated upon because they were poisonous, and lots of organisms there hadn't developed almost immunity to the poison, and so therefore their numbers increased, and they've now become quite a widespread pest, and in this case they become more of a pest than the original beetle. And so learning whether an organism that you introduce could have a positive or negative effect on the level of biodiversity is basically the whole key to this type of management. You need to make sure that the thing that you're introducing only targets the pest that you're after, and what you don't want is it migrating to different areas and having a huge knock-on effect. And so obviously there needs to be lots of studies and lots of research done in order to determine whether introducing a biological control is safe or not. So this leads us to integrated pest management, or IPM. And essentially this integrates practices from both using biological controls and by using chemicals. And essentially it's done, basically it uses the most effective systems it can to produce the highest yields at the lowest cost. And so you would expect someone who's using integrated pest management, they'd use chemicals and they'd also use biological controls. And these are always usually done in unison. And so some of the major advantages of it, it means you don't have to use as much chemicals, so saving money. It may give essentially it may give a solution to a problem that chemical control hasn't been able to eradicate. Obviously you don't get such a huge quick build-up in resistant strains of organisms to pesticides. Obviously for the people working on these areas, the chemicals that we're using are not particularly pleasant, and so there's a reduced risk because you're losing less. Obviously you don't get as much build-up of these chemicals within your food, so they don't bioaccumulate. It means that farmers can actually take on new solutions, and so they're not fully dependent upon chemicals, and obviously it reduces the damage to the environment. Some of the major disadvantages, it can be expensive, and so to coordinate it and to understand it, you need to know what to apply when. And so it's much more complicated than knowing, well, I apply this chemical this often. With IPM, you need to be very specific about when you're going to apply the biological control, when you apply the chemicals, and so you need a greater understanding of that. You obviously need to monitor more regularly, and so again this is time consuming and there are cost constraints to this. And obviously more than using chemicals, it's much more difficult to establish the timings, and so therefore you'd need to do more research, you'd need to look at it more in depth, and again that's a time and money constraint.